Alright, so let's get started with Module 3, Aircraft Maintenance and Supply Chain Support. Welcome to Module 3 of our Airline Engineering Supply Chain course. Today, we explore the various types of aircraft maintenance, line, base, and heavy, and dive deep into how supply chain teams enable these functions to run efficiently, safely, and on time. Let's get into it. Line maintenance is the day-to-day frontline care of aircraft. It takes place at the gate or on the apron, wherever the aircraft lands, and includes things like routine checks before and after flights, also known as transit checks, minor repairs, for example, replacing a brake unit, and component replacement under MEL, or Minimum Equipment List guidance. Example: a Qatar Airways A350 lands in Frankfurt, and the crew reports a fault in the nose landing light. The local line maintenance team refers to MEL guidance, removes the faulty light, installs a spare from local stock, and clears the fault before the next departure, minimizing downtime. So the supply chain's role is to maintain rapid access inventory at major hubs and, use rotable pooling for high-cost items like avionics and actuators. They also coordinate AOG support via logistics providers. If the right part isn't available, the aircraft could be delayed or grounded, impacting both schedule and profitability. Base maintenance involves more in-depth scheduled checks, and these are typically performed at the airline's main engineering base or a contracted MRO. This includes A checks, which happen every few hundred flight hours, and C checks, usually every 18 to 24 months. There are also interior refreshes, software updates, and deeper system inspections. For example, a B787 is flown to Doha for a planned C check. The base maintenance team inspects structural elements, overhauls several components, replaces seat fabrics, and performs software updates. So let's talk about the supply chain's role here. They need to forecast demand based on scheduled maintenance plans, pre-position repair kits and tooling, and coordinate with OEMs for those long lead time components. Plus, they have to make sure all parts have proper airworthiness certifications. Here's an insight for you. A C check may actually involve over 1,000 part numbers, each needing traceability, proper handling, and on-time availability. Just imagine, a missing seal or an outdated service bulletin could cause major delays. This is honestly the most extensive and costly type of maintenance, often referred to as a D check or HMV, which stands for Heavy Maintenance Visit. It takes place every 6 to 10 years. Activities include things like a complete airframe strip down and inspection, corrosion control and structural repairs, as well as landing gear and engine overhaul. Those are done separately, but still coordinated. You'll also see major avionics upgrades. These checks can last up to 60 days and are usually outsourced to certified MROs, mainly due to capacity, specialization, and of course cost reasons. Now, when it comes to heavy maintenance, the supply chain's role gets even more complex. They're responsible for long-term planning with lead times of 6 to 12 months. They manage complex procurement contracts with vendors, schedule bulk shipments of materials, and coordinate with engineering for part supersessions, service bulletins, airworthiness directives, and life cycle updates. It's a lot to juggle, honestly. So, here's an example. An airline sends its A330 fleet to a third-party MRO in Singapore for heavy maintenance. The supply chain team must make sure that all required parts, like structural panels, galleys, and engine mounts, are shipped well in advance and aligned to the MRO's workflow to avoid any delays. Maintenance isn't reactive. It's actually strategically planned, and the supply chain is looped into every step along the way. Most airlines operate maintenance planning departments, which forecast checks using fleet utilization data and maintenance intervals. These forecasts are then shared with material planners, procurement teams, warehouse teams, and logistics and freight forwarders. Smart supply chains use MRO software integration, like Amos, Trax, or Ramco, to generate predictive part requirements. Here's another example. Predictive analytics indicate higher failure rates for electrical relays in hot weather operations. So, the supply chain pre-buys and positions extra units in Dubai and Doha, which really helps reduce turnaround time. Not all parts are used and discarded. Many high-value components are repairable. Rotables? These are parts that can be removed, repaired and reused, like hydraulic pumps, avionics modules, wheels and brakes. Example. A Boeing 777 brake assembly is removed after 800 landings and sent to a certified repair shop in Germany. Once repaired, it returns to the airline's stock. Supply chain's role: manage repair loop timelines, track component removals and warranty eligibility, and balance spares inventory versus repair cost. Some airlines use power-by-the-hour contracts for rotables, transferring inventory and repair risk to the vendor. So, for example, under a PBH contract with Collins Aerospace, the airline pays a fixed rate per flight hour, and Collins guarantees part availability and handles repairs. Maintenance requires more than just parts. You also need specialized tooling and GSE or ground support equipment. This includes things like engine stands, hydraulic testers, calibration rigs, jacks and safety gear. For example, a CFM56 engine needs a specialized sling and cradle to be removed safely. If it's not available, the entire maintenance job is, well, delayed. So, the supply chain's role is actually pretty crucial here. They need to maintain a calibrated tooling inventory, track the tooling life and serviceability, and also coordinate tooling sharing across stations, or even manage contract rentals. In global networks, this is, often supported by tooling control centers that issue, track, and recall equipment based on job schedules. Every part used on an aircraft must meet strict airworthiness requirements. Parts have to be traceable to a certified source, supported by an EASA Form 1, FAA 8130-3, or something equivalent. And of course, they need to be properly stored and handled to avoid contamination. So, for example, a batch of bushings received without proper paperwork is quarantined, investigated, and returned to the vendor, even if the part itself is technically correct. Supply chains must ensure zero tolerance for unapproved parts. This requires, quality inspections at receiving, robust vendor audits, and centralized document control systems. Using a non-certified part can result in regulatory penalties, grounding, or honestly even worse, serious safety risks. Aircraft maintenance comes in multiple layers, from rapid response line maintenance to multi-week D-checks. Each layer has unique supply chain requirements. Line maintenance needs speed and availability. Base maintenance needs planning and precision. And heavy maintenance demands deep coordination and long lead times. Supporting all this is a complex ecosystem of rotables, tooling, predictive data, and compliance documentation. A well-run engineering supply chain doesn't just support maintenance, it actually drives reliability, compliance, and operational excellence. In Module 4, we'll look at spare parts management, including forecasting, pooling strategies, and logistics models. Like, subscribe, and comment if you've found this valuable. And let us know what maintenance challenges you face in your airline or MRO operation.